Hey guys, today we're going to take a look at lesson 3.4, permutations and combinations. So the first thing I want to talk about is factorials. Factorials are when you have that exclamation point. So n factorial is n times n minus 1 times n minus 2 all the way until you get down to 1. So I have some examples below. First off, just something to know, 0 factorial equals 1. That's just 0 factorial equals 1. 4 factorial, you have the number that you're starting with, 4, times 1 less, times 1 less, times 1 less. So 4 times 3 times 2 times 1. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And then 9 factorial, you can see there as well, counts down from 9 all the way to 1. Those factorials we see in our formulas, and that's why we want to talk about them. So permutation is an arrangement of objects where the order matters. So a permutation of n objects taken r times is the number of different permutations of n distinct objects taken at r times p of n and r equals n factorial over n minus r factorial. We also have MathProb 2 in our calculator, which will help us do our permutations. Let's take a look at an example. Find the number of ways to create a 4-digit code in which no digits are repeated. This means that the order matters. So the order matters tells us it's a permutation. How many objects are there? We're dealing with digits. So we know that there are 10 digits. And then it's a 4-digit code, so the number of times a digit is taken is 4 times. So our permutation is 10, choose 4. So following our formula, that's 10 factorial over 10 minus 4 factorial, or 10 factorial over 6 factorial. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 factorial. So these are all going to cancel out and leave us with 10 times 9 times 8 times 7, which leaves us with 5,040. If you use MathProb 2 in your calculator, and you put in your 10, choose 4, it's also going to give you that 5,040. Let's try 2 more problems. 43 race cars started the 2007 Daytona 500. How many ways can they finish first, second, and third? So these are places in a race, and the places matter. So we know this is a permutation. How many objects are there? There's 43 race cars. And how many times are we taking them? 3, because we're looking for first, second, and third. So it's 43, choose 3. And that would be 43 factorial over 40 factorial. If we plug that into our MathProb 2, you can tell us 74,046. I want you guys to try example 3 and then pause the video, come back for the answer. Okay, here's our answer. There were 21 flavors to choose from, and he's choosing 3 of them. So permutation 21 choose 3, 21 factorial over 18 factorial, 7,980. Then we also have our combination. Combination is an arrangement of objects where the order does not matter. So we still have n objects taken r times. This is, that should say combination. This is when order does not matter. So it's n factorial over n minus r factorial times r factorial, or MathProb 3. So let's look at an example. TxDOT plans to develop a new section of highway and has received 16 bids for the construction companies. TxDOT plans to choose 4 companies. Order does not matter. How many different combinations are possible? So there's 16 objects, there's 16 construction companies, and TxDOT is choosing 4. So it's a combination of 16, choose 4. So be 16 factorial over 16 minus 4 factorial times 4 factorial. So 16 factorial over 12 factorial times 4 factorial. And when we draw that out, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We know that our 12 factorial is going to take up all of those 12 spaces. So those all cancel out. And we still have that 4 factorial as well. So 4, 3, 2, 1. And if we do those multiplications and divisions, we come up with 1,820 ways. If you do math prob 3, 16 choose 4, you're going to get the same answer. Let's try these 2 examples. Wendy has 9 different toppings you can get on your hamburger. You want to choose 5 toppings and do not care about the order. How many combinations of 5 toppings are possible? So our number of objects is 9 for those 9 different toppings. We're choosing 5 of them. So 9 choose 5, 9 factorial over 4 factorial times 5 factorial is going to give us 126. I want you guys to try example 6. Pause the video and come back for the answer. Okay, for our last example, Janie has 50 songs on a workout playlist, and she wants to make a playlist with 8 songs on it, and the order of the songs doesn't matter. And so it's 50 choose 8, it's a combination. 50 factorial over 42 factorial times 8 factorial gives us 536,878,650 possible playlists.